Okay, almost there. Then let me go to the textbook. Okay, then I can do this. I'm done with the share with the recording. Let me then share the screen. I just share my screen. Can you see my screen that side?
Yes, sir.
Okay. Then let me go to the textbook, the statistics. I think around page 300. Around the 300, if I'm not mistaken. And this is okay. So we are here. Is my zooming okay?
Yes, sir.
Oh, all right. Then we are going to do these statistics. Let me enable my ball pen here to highlight some things. All right. All right. So we are going to do this chapter 10, and then here they're just telling us that in previous grade, we only worked with the scenario that has got only one variable. And I think you know that, and they only maybe gave you some numbers, maybe 1, 10, 11, 13, whatever, and then they require you to calculate the mode, the median, I think the standard deviation and the mean. You are familiar with that, right?
Yes, sir.
All right. Can you tell what is the mode in statistics?
Oh, okay, hold on.
The mode. We've got the mode, the mean, and the median.
The mode is the most common value, sir. So the number we see the most.
In the data. Okay, 100% correct. I agree to that statement. And then what is the median?
The medium is the middle. So yeah, the middle.
After you arrange the data.
Yes, sir.
Because if we have got something like 34, 6, 7, 50, 100, and 10, 11, 1, 5. You first have to go to this data and then put it in order of ascending order. And then now you can extract the median. You can't just extract the median if this order is unordered. So, okay. And then what else? We've got the median, the mode, and then what is the mean?
So I wouldn't know the definition, but I know how you calculate it. You take all of the values, add them together, and then put them over the number of values of the of
Okay,
everything.
100% correct. I don't even think there is a need for you to know the definition because there is nowhere you are going to be required to define. But yes, you're going to be required to calculate. Yes, that's correct. Then let's continue with this part. Then this paragraph here is just telling us that we will now consider scenarios where there are two variables involved. There will be two measurements for each observation. We will also investigate the relationship between those two variables. So now we are no longer going to look at some data of only variable. So back then, maybe when they were talking about maybe the size of the shoes, they were only talking about that size of the shoes. Now they can happen that if maybe we are talking of Didintle, Desmond, Tabo, whoever. Now those people we can say are observations. Okay, now those observations have got two variables. Let's say in this case, those two variables will be the shoe size and the height. So yes, we are going to consider that as something that is like this. Do you get that?
Yes, sir.
All right. Thank you. Oh man, I love today's energy. I wish everyone there in class can have this kind of energy. I'd love it. It's good.
Thank you.
Super good, man. I like it. So we go proceed to this part, the scatter plots. They are saying now to us graphically, because yes, I mean mathematically, as long as we have data, you can express that data graphically. But now, in this part of ours here in statistics, graphically, the relationship between two variables can be shown by means of the scatter plot here in statistics. Because if you have got two variables, graphically, you can do, I mean, a lot of plots. It can be bar graph, a histogram, or anything. But for now, we are still talking about only the scatter plot. Okay, and then one variable is placed on the part of the x-axis, which is this one, the horizontal one we know on the graph, and then the other one is placed on the side of y-axis. Excuse me, we know that is the vertical one, the y-axis. Fine, okay, and then corresponding values of the variable are plotted as coordinates on the Cartesian plane. Therefore, now let's quickly go to this example one that I'm having here on the screen. Okay, they give us something about grade 12. They are saying the grade 12 mathematics marks. Okay, the X part represents the mathematic marks. Okay, fine. And then grade 12 physical sciences marks. That Y now represents the marks of physical sciences. Okay, 15 learners are below in the table. Therefore, okay, we've got these results here. These are the results for a student. If this Didintle, this will be Didintle. If this is Peter, this will be Peter. If this will be John, that column will be all for John, and so on. Okay, now we know from the statement that this X, the first row, is for the mathematics marks, and we know that this second row is for the physical science marks. Okay, now we can see, okay, the first got 10 in maths, 15 in physics, the second one, 30 in maths, 33 in physical sciences. The third one, 35 in maths, 40 in physical sciences, and so on and so on and so on. Therefore, now this is what we are required to do. You are just required to represent that on the scatter plot. So like they said there, that when you use the scatter plot to represent something, you take other variable, you put on the x-axis, you take the other variable, you put it on the y-axis. So here they made things be simple for us because they already told us that, okay, for maths, we know that is for x-axis, for y, that is going to be physical sciences. So, okay, we are just going to sketch. Okay, in fact, for you, grade 12, on your answer sheet, you will have this. This, what is this? It's a graph paper. Okay, you will be having this graph paper, and it will be empty like this, and then you can just use that information. Okay, math is the x-axis. Then you come write it here. That okay, on my x-axis are the mathematics marks. Then after that, you come to this part for the y-axis, as they said, that is going to be physical sciences marks. Is that okay?
Yes, sir. Yes, sir.
All right, thank you. Then now, after labeling your axis, okay, you can just look maybe at your your numbers there for the trend for your scale. If maybe your scale here will accommodate that data. If your scale here is maybe 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, up to maybe whatever maximum number it can be, or it will be fine as 10, 20, 30, 40, 50, 60, 70, 80, 90, or okay, if that one doesn't work, you can maybe try 15, 30, and so on and so on. or maybe 20, 40, 60, 80, and so on. Does this one make sense?
Yes, sir.
Okay, thank you. Then they decided to use their scale for the x-axis as 10, 20, 30, 40 up to 90. Also for the y-axis as 10, 20, 30, 40, 50, 60 up to 90. Fine, that's our scale. We haven't plotted anything yet. So what now are we going to do? We go to Didintle as the first student. Oh man, I'm sorry to just pick you as the lowest.
Okay, sir.
Let's say, let's say let's say because now Didintle is my student and Didintle will never disappoint me. This is Didintle. She will
Yes.
never disappoint. She will never disappoint me. She is smart. I know. I believe in her. That's going to be her. So let's say this is Peter. Let's take Peter now. We are going to plot the data for him there. Okay, Peter for X, which is maths, there it's 10. Okay, then you go for 10. 10 is somewhere here. Okay, you go for 15 for Y. Okay, it's gonna be the half or the midpoint between 20 and 10, which is going to be somewhere. Hey man, what am I doing? I'm sorry. It's going to be something that is I here that midpoint. Therefore, now our point is just going to be this one as they did that one there. Okay. And then you go to the next one. Let's say this one is John. You go to John, and then X is 30 there. Okay, you'll go for this part, that one there, and then the Y is 33. You will count there on your graph, and then you go to 3. It will give you this point, and then with this, you do the same thing even with others. You go for the X value also and for the Y value you sketch them until the last one, then you will be done. Does it make sense up to so far?
Yes, sir.
Are you sure?
Yes, sir.
All right, thank you. Then let's proceed to the next part. The next part here is this one. They are saying the line of best fit. The line of best fit, you can also call it least square regression line. Least square regression line, the line of best fit. So they are saying there a linear relationship may exist between two variables. And you can see that line by only looking at this table. By only looking at this table, you can't tell me what the trend is until you sketch the scatter plot. Okay, you will see what I'm talking about. Okay. And then they are saying a linear relationship may exist between two variables. The straight line that best represents this relationship is called the line of best fit. We know that, or the least square regression line. Fine. Now, statistically, maybe someone can come from physics and come argue with us and disagree with our point. It's fine. It's their concern. But statistically, the line of best fit is such that the sum of the squares of the vertical distance between the point and the line is minimized. We will use the calculator to find equation of the least of square regression line. I don't know if we already did that using calculator, to play around statistics.
Yes, sir. I've
Oh
learned about
man.
it.
Oh, that's super good. I enjoyed pressing the calculator a lot when I was doing my matric, big time. From trigonometry, or Euclidean geometry, I didn't use the calculator a lot. But trigonometry, statistics, or analytical geometry, I use the calculator a lot.
Yes, sir. It's
I
very
mean,
helpful.
it's very helpful. Even pressing 1+1, I ensure that I use the calculator for that one because I don't want any mistake, eh?
Yes, sir. Yes, sir.
I
Definitely.
don't. Yeah. If even those equations, do you see those equations in question one? Those whereby they say solve for x and then they give you
Yes,
something
sir.
like
Yes, sir.
quadratic equation. Yeah. I ensure that okay. I can only maybe first factorize it by looking at it. Afterwards, I'm going to take it into the quadratic formula and be sure.
Yes, sir.
Afterwards, I will take my values and substitute there in the equation, see if they give me 0. That's how I did it. I didn't want any mistake.
Yes.
So yeah, it's wise for you to ensure that you avoid mistakes as much as you can. Yeah. Then now let's get back to the business. Okay, they are saying now again on the second paragraph, the equation of the best least square regression line is written as, oh, this is it here. Y hat is equal to a plus bx. Okay, seems familiar. We know this from, algebra. Maybe B here, right?
Yes, sir. Yes, sir.
Yeah, you know this from algebra, and then that this is a gradient, this is the y-intercept. The only difference that we are having now here is that now in statistics we've got something like the y have got head there. It's sunny day out here, so y is
Yes.
protecting himself with some head. So let's continue with the statement. And then they are saying where that constant in the equation, is the y-intercept, just like we know it from algebra. It doesn't change. Fine. Okay. Of the line, okay, and B is the gradient, since B is the coefficient of x, is the gradient of this line. So even this B is the same as that M from algebra. Okay, now they are telling us about that head on the y. That head on the y is to show that the equation represents a trend. There's some trend there and doesn't give actually y values, but predicted y values, some estimated values of y based on the trend. More about this later. That's what they are saying. The following fact is very, very, very important. That's what they are saying. So let's see this note that they are saying is important. So you also need to note that this is important, just like they say. Maybe if you don't know this something that they are saying important, we might miss something out. So let's just go together through it. They are saying the least square regression line always passes through this point. Can you see that point?
Yes, sir.
Do you see something familiar there?
No, sir.
Oh, okay. Can you maybe tell me what is this?
What is what, sir?
This thing that I've written here, this one.
Oh, an X, sir.
Okay, then I put that thing there. What does it mean?
The mean.
Yes. Now you get it because of that line. Okay. Therefore, now this is going to be the mean for that data that they said it's for the x-axis for the math marks now, and then for this one now is going to be the mean for this data.
Okay, sir. Yes, sir.
So yes, because the mean is not points, but the mean of just one variable is just a number. Let's say maybe the mean for this data, let's say maybe it's 10. And then the mean for the y values, let's say, is 24. Therefore, now this means gives us something like coordinates. Can you see that?
Yes, sir.
Therefore, that important note there on the background is trying to tell us that the least square regression line will always pass through these coordinates that are given by the means of these data on the table. Does it now make sense?
Yes, sir.
Are you sure?
Yes, sir.
Okay. Then now let's proceed to the next part. The least square regression line always passes through the point. Okay, we know that. Now, to sketch the least square regression line, we plot the point. We plot that point that we found from the mean for the x values, y values. And now, and at least 1 point. 1 point.
Sir?
Already. Sorry?
Sorry, can I interrupt you, sir? I can't really hear you.
You can't really hear me?
Yes, sir.
Oh, so now can you hear me? Maybe?
The volume went down like by a lot, sir.
I wonder what happened. Let me maybe check something this side. I wonder what happened. I wonder. Let me just check with my mic if there's something. Can you now hear me?
Yes, sir. Thank you, sir.
Like properly?
Yes, sir.
Oh, okay. Let me share back my document screen. I share the screen and I go back to the document. Okay, I was here. So I was talking about this part here. I was reading this part here. So this part they are saying to sketch the least regression line, the least square regression line, you first need to go have this point that you got from the mean for the first variable and the mean for the second variable. Just know that the least square regression line is going to pass through that point. Okay. Then the second one is obviously going to pass on that constant a, because that's obvious, and the y-intercept, so it will automatically pass through that point. So now you have 2 points that you can join. Is that one from the means? You also join this constant here. Are you now okay with that?
Yes, sir.
Okay. Oh, then they already said, then you connect the 2 points with a straight line, then now you have got the line of best fit. Okay, then let's go to example 2. Example 2 here is saying, oh, it's a continuation of that one. They are still repeating that, okay, the grade 12 marks for maths are represented by X. The grade 12 physical sciences marks are represented as Y. Okay, of the same 15 learners are given in the table below. Now we know that table. Then number A is requiring us to calculate the mean of mathematics and physical sciences marks of these learners. Can you tell us how we can just do this using a calculator? Do you have a calculator with you there?
Yes, sir.
Oh, better. I'm also having mine this side, so I will just hear from you what you can do.
So don't we go to mode and then press 2, go to stats, and then
Oh, yes.
you press 1, and then you put all your variables.
Okay.
Are we calculating the mean, sir?
Yes.
Yes, sir. So then we take all of our variables.
Sorry a bit. Can I please disturb you before you continue?
Okay, sir.
Oh, yes, you chose mode and then you chose 2 for stats, and then you went for number 1, right?
Yes, sir.
And then can you see that option for number 1? It's just one variable. And
Yes,
then
sir.
when you press that one, it only gives you the column for X. So I would advise you to go yes for option 2, stats. And then option 2 again, that one that I've got, A plus BX. That is one is for the 2 variable. And then it will be easy for us to find that A and B and correlation coefficient.
Okay, thank you, sir.
Yes. So
I was
now
going to do it one by one, but thank you,
yes.
sir.
Yes. So now can you see that after going for that option, it gives us some 2 columns for the X values and for the Y values?
Yes, sir.
Yes. Then you can now simply put the X values as they are from the table as they are. Also on the Y, you put them as they are. And then now, after you're done, most you know how to put them, right? You just press
Yes.
the number, you press equal, then you put it. That number equal, then you put it.
Yes, sir.
And then after you are done with that, you just go back to your AC, I think you know that. And then
Yes.
now, okay, the question, we go back to the question, calculate the mean for these both things, for maths and physics. Now what we are going to do, we're going to shift and number one stats. Okay, we are there now. There are those options. Number one is type, two is data, three is sub, excuse me, 4 is var, and then 5 is regression, and then 6 is min-max. That one we can use this to calculate the range. Okay, then us, because we want the mean, we're going to go for that option number 4. Then there it is. So we can see now that option number 2 is the mean for x, and option number 5 is the mean for y. Then now you can just go for option number 2 first. You write your mean, and then you go back again for shift stats option number 4. You go for option number 5. Then it gives you the mean for the variable y. Does that make sense?
Yes, sir.
Are you sure?
Yes, sir.
Oh, okay. That is for mean. Let's go for the second equation. Now the second one, number B, is saying determine the equation of least square regression line. That one you know, okay. You do the same thing. It's shift stats, and then you go for, or not for now, it's shift and then one. Regression is number 5. You're gonna go for regression. Therefore, you will find all these things now. The option number 1 is A. Then you find your A, you write it, and then you find your B, you write them, and then you substitute them on the equation, and then that's your equation. Does also this part make sense to you?
Yes, sir.
Are you sure? I don't want you to say maybe you are sure that you understand, maybe because you are shy. Just don't be shy, shout it out if you don't understand, then so that you can
So do
be
you
all
mind
okay.
just going over B just one more time so I can make sure that I make sense of
Oh,
it?
oh, oh, over B.
Yes, sir.
Oh, okay, okay. Must we put, we are now done with putting the data on the calculator, I mean, in that table, right?
Yes, sir.
Then now we just go to shift, we go to option 1, number stat, that one for stats. You know that thing, right?
Yes, sir.
Yes. So we want to determine the equation of least square regression line. That regression here in this calculator, because the calculator, I think, it doesn't have the enough space to write that word regression. So it is represented by that option number 5. It is written reg there. I'm not sure if you can see it on your calculator that side.
Yes, sir.
Yes, then you will simply go for number 5 option. Then there are another options 1, 2 up to 5. Then 1 and 2 are the ones that we are looking for the value of A and the value of B.
Okay, sir.
Can you see them?
Yes, sir.
Are you sure?
Yes, sir. Yes, sir. I
Are you
can.
now are you now compatible with that?
Yes, sir.
Oh, then can you tell me maybe what can I do to find the value of A and B?
No, sir.
Yeah, can you?
No, sir. No, sir. No, sir.
Okay, let me repeat. Let me repeat again. Okay, what the first step is the one that you know. It's shift and number 1. That one you know.
Yes, sir.
And then it will give you these options number 1, 2, 3, 4, 5, and 6 for the type, data, sum, var, reg, and min max. Right?
Yes, sir.
Do you have them that side?
I'm getting them, sir. Please hold on.
Oh yes. Then we go to option number 5 there, the one that is written reg there.
Yes, sir.
We go for it, we press that 5, then it gives me these options. What is appearing that side?
Uh, Sir, can I please start over because I don't know what my calculator is showing me, sir.
Actually, let's just do the real thing and insert this data. This one that we are having on the table. Let's just do it like that. Let me restart here. And then go to mode number 2 stats. Number 2 for AB plus X. How am I going to do for the X? You've got 10, you've got 30, you've got 35, you've got 40, you've got 50, 52, 60, 65, 70. Oh, you need to be super careful when entering this data because one mistake, I think, hey, you messed up with everything. So you just need to be careful when entering that data. 80, 90. Okay, I'm done with the X ones. Let's go for Y. Y is 15, 33, 40, 30 and 40 again, 55, 50, 70, and 70 again, 68, 80, 65, 70, 85, 90. Oh, I'm done. Then now, are you done with the data that side?
I'm almost done, sir, but you can carry on, sir.
Oh no rush. I can just wait for you. If maybe time is up, then we can just maybe add some minutes after just to make sure that we are comfortable with everything.
Okay, I'm done, sir.
You are done entering the data.
Yes, sir.
So okay, well, let me quickly do this. I'm going to ask you these questions. Let me hide these questions.
Okay, sir.
I mean, these answers. And now let's go. Okay, now let's find those means and tell me what do you get for the mean of the X values.
Okay. So, sir, after inserting everything, I go AC, then I say shift 1, and then
Yes.
option 5, REG, sir, or data first.
Oh yes. For the regression one, yes, you go for number 5. Yes. Oh, and then what appears that side?
1A, 2B, 3R, 4 a sign, and 5 another sign, sir.
Oh, okay. That 4x with some head, 5 with y with some head. Okay, yes. Now we know that that equation is something like this is equal to a plus b. I don't think it matters that thing that ours now is small letters, theirs is the capital letters. A is A at the end, B is B at the end. Therefore, yes, to find this one, yes, you press 1, then it gives you A, then equal sign, then you substitute it there. You write whatever you got, plus you go back again, shift 1, you go for rec, then you want B now, you press 2, equal sign, and then whatever you got, you write, and then X.
Okay,
Then
sir.
Y head here. Are you now okay?
Yes, sir.
Are you sure?
Yes, sir. So I calculate A, then B, then add them together, sir.
Okay, it's like this. Yes, you're going to write this addition sign here. Y this head is equal to, you write whatever you got for A plus whatever you got for B, then X. You can't maybe, let's say if you got A as 2 and then you got B as 4x, you can't add them to be 6 something. You leave it as it is 2 plus 4x because these are not like terms. They're
Yes,
just
sir.
unlike terms. So you leave it like this.
Yes, sir.
Yes. Are you now okay?
Yes, sir.
Oh, okay. Then now let's quickly go to the next one. The number C one. The number C is saying throw the least square regression line of the scatter plot, of the data. So now this is the scatter plot, that line, that solid line. So I'm going to ask you, how did they draw this line? Can you maybe tell me?
Okay, so I think we would plot the mean
Because
x and the mean y at the
did
least.
sorry, can I please interrupt you a bit?
Okay, sir.
Can you still remember how we did got those points? Those small dots?
Didn't we just plot it? Put
Yeah,
the
we
marks.
just plot them, yes, from these marks. Okay, you still remember that. I love it. Okay, you can continue with the explanation of that solid linear regression line.
Okay, so what I think we would plot the mean point, the mean x and the mean y at the least.
Yeah. Which is this one, right?
Yes, sir.
Okay, that's okay.
Using at the
And then?
So is there some sort of calculation that comes in with like plotting this?
No, this straight line, it doesn't even need a calculation because, okay, you already have your means, then you just go put that dot there. Okay, then on the equation, this one, a plus bx, we said this is the y-intercept, then you take that value, you plot it on the y-axis, then you join the two lines.
Yes, sir.
Does it make sense?
Okay. Now it does sort of, so yes.
So sort of means, I mean, you're not yet confident with it.
So maybe try another question and let me see if I could attack it, sir.
You want me to maybe re-explain this, or you're okay?
You could re-explain it, sir. It's okay. But if we maybe chose another question and me see where the confusion is, because for the most part, I do understand what you're saying and what you're explaining to me. I'm just confused somewhere. I don't know
Oh,
what's
okay.
confusing me.
Okay, then let's just continue. Then I will send you on the inbox some problems that you can go work them at home. Then you can submit maybe even tonight or maybe tomorrow after you are done with them.
Yes, sir.
Yes. Then, okay, we are done with this example too. Now we can go to this correlation. Okay. The linear correlation between two variables refers to the strength of the linear relationship between these variables. Variables can have a positive correlation, negative correlation, or even no linear correlation. There are only those three options that you can have with the trend between the variables. Is the positive correlation, the negative correlation, or there is no correlation at all? Do you understand those three options that you're having?
Yes, sir.
Okay, so we have got something here. If your data after you plotted it, it gives you something like this, that is a positive correlation. I mean, the increase in line, the one just like the one just we did up there, that is a positive correlation. And then If it's like this, the negative gradient or the decreasing trend, that is a negative correlation. Okay. Then this one, they occupy every space in the quadrant. I mean, there is no linear relationship in this one. Therefore, there is no correlation with this one, the third one. So now, do you understand the difference between the three?
Yes, sir.
Are you sure?
Yes, sir.
Oh, all right. Thank you.
Definitely, sir.
Then, okay. Then correlation coefficient now. Correlation coefficient. The correlation coefficient is being represented by that small letter r. So wherever instead you see the small letter r, that is a correlation coefficient. Okay. Then is a numerical value between -1 and 1. Do you get that part? That correlation coefficient is the numerical value that is between -1 and 1. Once you get something like 10, no, just know that you did something wrong maybe with the correction of your data.
Okay, sir.
Yes. Okay. That measures the strength of the linear relationship between two variables. The correlation coefficient indicates how well the least square regression line represents the data. Roughly speaking, the more the points deviate from the least square regression line, the lower the correlation coefficient. We will use the calculator to find the correlation coefficient. Yes, indeed, we can use the calculator. Okay, so we can go to the calculator. You do the same thing, shift and 1. You remember that thing, you go for number 5. For that regression, number 5, can you see that option 3 there is R?
Yes, sir.
Yes, then whenever they require you to calculate the correlation coefficient, you go for that option for R. Then our R in this case is 0.95. And indeed, that number is not greater than 1. Then it's a valid correlation coefficient. That's okay.
Yes, sir.
Does it make sense?
Yes, sir.
Oh, okay. Thank you. Then I want to emphasize this part. Where is it? Here they say, do you understand what this part is saying here? That the more points deviate from the least square regression line, the lower correlation coefficient will be, then vice versa. Can you see that statement?
Sir, do you mind zooming in? I'm having trouble seeing where you're reading, sir.
Oh, okay. Okay. I was talking about this line here, starting from this part here, this one. Can you now see?
Yes, sir.
Oh, yes. I was talking about this line here. That the more the points deviate from the least, like that line, that solid line. If these points deviate from that line, just know that the correlation coefficient will be lower. But will be lower, the correlation coefficient, if those points deviate from the line.
Okay, sir.
Then if they don't deviate, the correlation coefficient will be higher.
Okay, sir.
Yes. And then now we have got this table here. Oh, this table is making things easier. Interpreting the correlation coefficient, you have got the scatter plot here. And we know that this is a positive linear correlation. Oh, okay, you can just interpret. This is the interpretation. So if R, we know that R is a correlation coefficient. If it's 1, just know that your points of data will just form the straight line. They will align directly on top of the line. Do you get that?
Yes, sir.
Yes. Then here it tries to tell us now. Okay, they are still clustered, but they are not all on top of the line. They are somehow on that that point, that point, that point, but closer to the line. But our R now will be between 0.8 and 1. That's a creator number, will be creator. Just like that part it says, the more points deviates from that part, whatever, the lower the correlation coefficient will be. Then it's still the strong positive linear correlation is positive and strong. Now we have got this one. Now they try to disperse a bit, then it will be between 0.5 and 0.8. Then you can comment moderate positive linear correlation. Are you okay with this part?
Yes, sir.
Okay, then let's go to this next one here. So I'm also going to share this table there on your inbox, maybe for you to just remind yourself with some things there.
Thank you, sir.
Cool. So we have got this one now, this one here, very, very weak one, because these numbers deviated from the line. That's why now it's a small number for the correlation coefficient. Therefore, we can say that it's a weak positive linear regression. It's a weak one. Okay. Then we have got this one now. Now we move from those positive and we do vice versa now. But it's just the opposite of those ones that we had up there. Just that they are negative. Are you okay with that?
Yes, sir.
All right. Then we've got the last example here. Example 3, they are saying the grade 12 mathematics, or they're still repeating that thing. Let's just go to the question. The question is requiring us to calculate the correlation coefficient R. And then, of course, I got 0.95 this side, and also they got R as 0.95. Do you still remember how to get that correlation coefficient, that R,
Yes.
using the calculator? Are you sure?
Yes, sir.
Oh, okay. If you're okay with that, then now comment on the relationship between the results for maths and physical sciences. Then they said it's the strong positive linear correlation. Why? Because there is a larger number for the correlation coefficient. Do you understand their answers?
Yes, sir. Yes, sir.
Are you sure?
Yes, sir.
Okay, then I will send you this example 4 here as something that you can do at home, and then I will also send the screenshot of this table here.
Thank you, sir.
Otherwise, we are done with today's lesson. Any questions regarding what we did today? Are you okay? Curious with something?
No, I'm okay, sir. I learned a thing or two, sir.
Are you sure?
Yes, sir.
Okay, man. Otherwise, I appreciate it being with you. I enjoyed the energy of today's lesson. This is one of the best lessons I ever had since I joined solving exam papers. That part,
Thank you, sir.
I enjoyed it a lot. This one was the best.
Thank you, sir.
Enjoy the rest of your Sunday. I will see you on the next sessions that we can have.
Okay, sir. Bye-bye, sir.
Sharp.